Welcome to Virtual Laboratory. I am Professor Uttam. Today we will discuss viscosity and Newton's law. We will determine viscosity in the laboratory. When fluid in motion, the layer above the other resist one another to flow. The resistive force acting opposite to the direction of flow along the surface of the layers in contact is called the shear force. You can see in the figure that this shear force acting opposite to the flow, the upper layer of fluid moving at higher velocity and lower layer of fluid moving at lower velocity. Newton's law of viscosity is shear force per unit area, which is proportional to the ratio of the difference of velocity of the layer to the distance between them. You can visualize in figure that two slices of fluids which are in contact is moving to different velocities, above u plus delta u and below is u, and distance between these layers is delta x, and the flow area in contact is the surface area, is a tau is equal to the shear force per unit area is equal to minus mu into del u del x, where mu is your viscosity constant or the constant of proportionality, is a property of any fluid which is very much unique. When a fluid flows in a system, the property is disclosed as a constant value as long as the temperature and other conditions are same. And now we'll go to the virtual laboratory to determine viscosity. There are many methods of measuring viscosity, but the simplest and one of them is falling sphere method. We'll discuss next. Now you can see this is the falling sphere method, where you find a large glass tank having a certain height from which a spherical ball will fall, and this liquid sample is taken in this glass, and we measure the time for fall. For a specific ball of given mass and the density of the ball as well as the radius of the ball are same everywhere. Now by this is a heavy acid is taken in the system, and that's why its density by default is 1.1 gram per cc, and the falling time is measured by the computer inbuilt stopwatch, and the height is already measured and this velocity is calculated, and then viscosity is determined at both in poise and Pascal second. Now we'll start with the heavy acid. At the start you will find that ball is falling. It's falling at a very low speed, and you can see that falling time and the height of fall and the velocity. And finally, when it will reach the bottom of the tank, it will show the viscosity in poise as well as in Pascal second. This is for heavy acid. So as it touches, the time velocity is known. Now it calculates the viscosity, and this value is recorded. Now if you take a lighter fluid like heptane, before that I have to stop this, then this ball will vanish, and then you take heptane. You can see the density is much smaller, it's 0.7 less than density of water. So we'll start here. Ball falls very fast, and it's difficult for physically measuring the time, which is possible here only because of the computer. Otherwise, you have to take a pretty long cylinder to measure the velocity. Now we stop it, and we see that viscosity is very small. And now stop it, and then we take glycerin, which is heavy. As far as the density is concerned, is 1.26. And in this case, we'll start. It will take time, and it's now falling, and time is being measured. As soon as it touches the bottom, we'll get the viscosity. So we obtained the viscosity is around 10.69 poise here, and Pascal second is 1.069, so 1/10. So we obtained the viscosity like this. So this is the method, very simple, and I tried to show how viscosity can be measured, but there are many methods. It may be passing through a specific volume, passed through a tube, is a viscometer tube, or it can be in a start tank, small start tank, where the power varies with the viscosity for different fluids, which can be calibrated with known fluid, and that also can be used. Now, there are certain fluids where the viscosity does not follow Newton's law. We call it non-Newtonian fluid. In that case, consistency index is used in place of viscosity, and that is out of the scope of this experiment. And now this also to be mentioned that it varies with temperature. So temperature of the experiment must be noted, as viscosity is a function of temperature. Thank you very much for watching this video.